Okay, the problem we're going to be discussing is as follows. When Galileo was formulating the laws of motion, he considered the motion of a body starting from rest and falling under gravity. He originally thought that the velocity of such a falling body was proportional to the distance it had fallen from. What do the experimental data in the table below suggest about Galileo's hypothesis? What alternative hypothesis is suggested by the set of data? And here we have the set of data as well, just below the problem. So the first part to the solution of this question is fairly simple. We just need to determine whether Galileo's hypothesis is correct or incorrect. And just to sum it up, if Galileo is correct, we're going to notice a linear trend for the function. And this is because he thought that the velocity was proportional to distance, which would give us a function that would look very similar to this. Like that right there. But we're going to fast forward a bit in the solution and pretend as though we've already discovered that this is incorrect. So the tricky part of this question comes into play, and this is just determining an alternative hypothesis. So it can be very easy to get stuck here and not really know where to start. So the problem-solving strategy we are going to suggest for solving problems like this is drawing a graph. And this is going to be helpful because it's going to allow us to visualize the data and the way it's changing over time. And then once we have the graph, we can characterize it. And based on this, we can determine how we're going to proceed and what might be a plausible alternative hypothesis to Galileo's.
A common issue when attempting this problem is justifying a function that best represents Galileo's data. Computing a function algebraically is difficult, given a table of values alone. Also, it is difficult to see the characteristics of the data through a table of values. We can see from graphing the data that this is an increasing function with a rate of change that is decreasing over time, approaching flat. Also note that all values are positive. This suggests that a radical function can be used as a model. Characteristics of Galileo's data become much more clear with a visual. Comparing a table of values of Galileo's data with a table of values of v equals root d, we can see that both sets of data are proportional to each other by a constant of 8. Algebraically, this can be seen clearly as we determine the value of the constant through isolation. To conclude, our model for Galileo's data states that velocity is equal to 8 times the square root of distance.